Okay, a pleasant day to all of you, to those who are listeners in this session. So for today's topic, I discussed last time rather about horizontal translations and vertical translations. Now we will just continue about the topic that we had just started about transformation. So to start, of course, we have the horizontal and vertical translation for this topic or for this session. Okay, let's review translations. As I mentioned last time, are transformations that shift all points on the graph of a function up, down, left, and right without changing the shape or orientation of the graph. So I guess I'll just highlight this one for a while. Okay, so the shape and orientation will not change in here. So a very important thing to remember about translation. Okay, so another thing also, we discussed about okay, we have here the function formed. Okay, this is the form for the vertical translation. And as we could remember, when k or if k is greater than 0, then the translation goes up. Or what I mean, it moves or shifted up. And then if k is less than 0, then you have the translation is moving down, okay? So the mapping can be represented in this. It is transformed or translated in the form of x and y plus k. As you can remember, your y will be added with your k. So as you can see the movement, okay, this is the movement that I introduced last time. So I hope you are guided. Okay. And another thing also, of course, when the function is in the form of y is equal to f of x minus h, then you can have it a horizontal translation. When h is greater than 0, then the translation is to the right, or it's shifted to the right. And if h is less than 0, then the translation is moving to the left. I hope we are clear about it. And of course, look at, as you can see, the h in here, of course, you'll add h to your k. So that's the form, or that is the mapping notation to get your ordered pairs or your, key points, shall I say. So you have it here. As you can see, the functions that we have moving left or moving left or right. So it shows there. So from y is equal to f of x as this one is our main function or the parent function or the base function. Then it moves from left to right, as you can see, to f of x minus h when it moves to the left, to the right rather, when h is positive. And of course, when h is less than 0, then it moves to the left, as you can see, to the green one, this one. Okay, so I hope you're clear about this one. So I guess we can proceed to the next, of course. Yes, we can. So now, here are the learning objectives for today's lesson. Of course, we're going to sketch the graph of y minus k is equal to f of x minus h for given values of h and k, given the graph of y is equal to f of x. And aside from that, we're going to write the equation of a function. This is the main focus in here, writing the equation given the function, whose graph is a vertical and or horizontal translation of the graph of y is equal to f of x. I hope we are guided about this one. So I guess, so you are guided so that you will be guided more. Please be guided with the guide questions. Of course, I want you to find the answer about this one while we are in our discussion, as we have our discussion rather for this session. Of course, how to illustrate the translation of function, that's the main thing. And of course, how do we describe a horizontal and vertical translation? And of course, how do we illustrate a horizontal and vertical translation of a given function? And how to determine the equation of a translated function. I guess this is the last one. Yeah, I'm right. Okay, so I want to highlight those, or what I mean, I want you to be guided with the questions that I post there on the screen, that I posted rather on the screen. Okay, so let's start with the graph of the translations rather. Okay, so the translation can be defined as the movement sliding of a shape to a new position, as I have mentioned several times in the previous video that we had. Okay, so if f of x plus a, you can just have it, the graph shifts up or down the y-axis by a unit. So do not forget that one. That's for your a, of course. And then if we have it, this a, it refers to your k, since it moves the up or down. And if f of x, if f of x plus a, then we have it, the graph shifts left or right along the x-axis by a unit. So it moves along the x-axis. So I want you to remember that one because your a here represents to your h. So from left to right, so it's up to you. Okay. So now adding to the function, please take the note of this. Adding to the function causes a translation. Do not forget that concept. If you add to the function something in it, then it will cause the function, or it will cause a transformation, which is called a translation. So now, if f of x, then given that we have here, so this is the f of x there, so you can just sketch f of x minus 3, then plus 5. So as you can see, your h is 3 units since your, yeah, as you can see there and on the function that we have, in the function that we have rather, so you have your h is equal to 3. That means your h is positive. It goes 3 units to the right. And of course, for your k, as you can see there, your k is 5, then it moves 5 units up. So I hope we are clear about this one. So if you're going to, only thing that you have to do is just, you will just add from the base function any, okay, you will just add any of the points in your f of x. Just add 3 to your h, or to your x rather, for your h, and then you add 5 or k to your y. It's like this: h plus x plus h rather, then you have it y plus k. So this is how you provide the translation in each function. Okay, just pick a 1 point or ordered pair, then just follow this rule, then you'll have the new one. So that's, you can see from here the vertex, yeah, we pick the, or we chose the vertex as its points or key points. Then for the transformed image points that we have now, it's located here, the vertex, as you can see. Okay, it's here. So that's how you do it. Just remember this one, then you'll have it. Okay, so that's very easy, I believe. I believe. Okay, so now let's go to another concept for better understanding about horizontal and vertical transformations. So, or shall I say translation? So your H refers to your horizontal translation or transformation, and your K is your vertical transformation or translation. So now for vertical transformation or translation, you'll just add K. So if you have it, if plus 4, then you have it 4 units up. If minus 3, then you have it 3 units down. Okay, for horizontal transformation, you have it here, this form. So we're always focused on your H. And as you can see, you have it here. If it's 5 units right, okay, if it's positive 5, then it's 5 units right. This is, okay, for correction, is x plus 4. Okay, if it's x plus 4, then you'll have it 4 units left. Therefore, that means your h is negative 4. So careful with your f of x minus h, okay? So if it's minus h, then it means your h is positive. If it's x plus h, then your h is negative. So please do not forget that one. A friendly reminder from me, of course, from Emma Watson, perhaps. Okay, from Mr. Alice there. Okay, so I hope we are guided. Another thing, yes. Okay. So horizontal, that's what I've said, going to the right. If f of x minus h is the form, so it moves h units to the right. So if it's left, of course, it's in the form of f of x plus h, it moves the function in h units to the left. And of course, for the vertical, we have up or down. For, of course, for up, what's happening in here? If we have it f of x plus k, it moves to the function k units up. And of course, for f of x minus k, of course, moves the function k units down. So I hope we're clear about this one. More of it. These are the rules. So perhaps you can just have it. It's like redundant. Okay, I just want you to focus on this. So if we have f of x plus d, then of course your y, you'll just add d to your y. Okay, for f of x minus d, you will subtract d to your y. And if you have x plus c, then you will just have it subtract since it goes to the left, then you are going to subtract c to your x. And if it's x minus c, that means your c is positive, it goes to the right, then you'll add c to your x coordinates. So that's it. This is just very simple for you if you'll just follow the rule. Okay, we have rules for your coordinates. We also have rules for your vertical translations, and we also have rules on how you graph it. That's it. You'll just follow it, then you'll get the correct answer or a correct location for your translation. Okay, so I hope we are clear about it. And let's go to our example number 2, horizontal and vertical translation. So sketch the graph of y is equal to the absolute value of x minus 4, then plus 3. So for the solution, of course, you have to identify your h is equal to 4 based on the function that we have in the given, and your k is negative 3. Then start with a sketch of the graph of the base function. Of course, as you can see, this is our transformed or translated function. So our base function is not like, this is not our base function, of course. We use absolute value, therefore our base function is y is equal to uh, absolute value of x. So that is our base function since we use the absolute value. So I want you to be guided with that. Okay, using the key points, of course, you know the key points, the ordered pairs or the coordinates. So apply the horizontal translation of 4 units to the right since h is equal to 4. So from the graph, y is equal to the absolute value of x minus 4. So to ensure the accurate sketch of a transform function, translate key points on the base function first. You can do that one. So as you can see, you move. Okay, I'll show it again. So from there, you'll move 4 units to the right. So that's how you graph it. Okay, next, apply the vertical translation of 3 units up to y equals the absolute value of x minus 4 to obtain the graph of x minus 4, absolute value of x minus 4 and plus 3. Okay, so I want you to remember that one. Why? Because I want you to do it one at a time. Okay, you do first the horizontal translation if there is, then followed by vertical translation. Horizontal, next is vertical translations. Okay, if you want to complicate yourself, then you can do the opposite one, the reversed way. Okay, but I bet you're going to do this one. Okay, I am expecting rather to that you're going to follow this rule. Okay, horizontal followed by vertical translation. So again, we did, or we moved, or we shifted, or we are doing rather, or we did the horizontal translations first. As you can see, 4 units to the right. Then after that, from the horizontal translation, then we will go to the vertical translation, which is, okay, moving 3 units up or shifting the graph 3 units up. And then after that, the point 0, 0 on the function, y is equal to the absolute value of x, which is our base function, is transformed now to become 4, 3. So this is our point, as you can see here. This is the 4, 3. So from the 0, 0, from the point of origin that we have here, from 0, 0 in here, as you can see, from 0, 0, the graph transformed into 4, 3, as you can see. And of course, in general, the transformation can be described as this one, x plus 4 and y plus 3. We add 4 and we add 3 to your 4 for your x and then 3 for your y, since your h is 4 and your k is 3. So I hope we're clear about this one. And of course, another thing that I want you to think about, key points are points on the graph, sorry. Key points are points on the graph that give important information, such as the x-intercept and y-intercept, the maximum and the minimum value. At least it will help you to graph the function. That transform function, I'm talking about the transform function in here, okay? Or translated function. So I hope you are guided. I hope you are not misguided or misled. Okay, so now let's go to example number 3. So you have actually two given in here. So you're going to determine the equation given the graph. Oh, this is something like a challenging one. Describe the translation that has been applied to the graph f of x to obtain the graph of g of x, then determine the equation of the translated function to in the form of y minus k equals f of x minus h. As you can see, so you have it here, the letter A, and of course the second one, letter B, and of course it's a convenient, it's more convenient to use the prime, the prime in here next to the letter representing an image point. As you can see it here, So we use the prime here to show that we have a new image. This is the new image coming or taken from this, or taken from the points of this function. So I hope we are clear about this one. Yes, Acha, you can do it. Okay, now let's go. Oh, it's gone by the wind. Oh, what's happening? Okay, now. So let's go to letter A. Of course, for letter A, as you can see here, A there, you have the quadratic function given, of course. So let's see. The base function, of course, is f of x equal to x squared, which is this one. This is the base function, so you can see. Choose key points on the graph of f of x is equal to x squared and locate the corresponding image points on the graph of g of x. So in short, you have to first locate the points that we have. So that is the very easy, of course. You do not locate the complicated one, only the basic one, okay? That can be easily identified. Of course, we have the 0, 0 in here and the negative 1, 1 in here. So you have it there. So as you can see, okay, negative 1, 1 here, negative 1, 1. Then we have it 1, 1 here, check. We have negative 2, 4 here, check. We have 2, 4 here, check. Okay, after locating it, of course, we have to get its the ordered pairs of the g of x. So the transform, which is the g of x, we name the transform function as g of x in here, the color red. Of course, you have it there. So negative 4, 5, negative 5, where is it? It's here. As you can see, negative 4, negative 5, negative 5, and 4, negative 4 rather, it's here, check. So negative 3 and negative 4, check, it's here. It's here. Okay, check. Negative 6 and negative 1. Okay, let's see. Okay, let's see. Here it is. Okay, so negative 2 and negative 1. So I have it. It's here. Okay, so as you can see, based on the given, what happened to your x? Of course, from 0, you have negative 4. It's easy to identify using this one. The first point from 0, 0 to negative 4, negative 5. So we have to subtract it. Of course, x minus 4. Subtract x with negative 4 since it is transformed to negative 4. The x coordinate from the base function to the transform function. So from y, you have it negative 5 based on it here. So you just did the same thing in here. So this is now the, of course, the image, the mapping notation that can describe to the image points that we have on the graph of g of x. Okay, we can describe the formula by doing this one, x minus 4 and y minus 5. Okay, you'll just do this one, then you'll have it. So for a horizontal translation and a vertical translation, where every point x, y on the graph of y is equal to f of x is transformed to x plus h and y plus k. As I mentioned a while ago, the equation of the transform graph is of the form of y minus k is equal to f of x minus h. Okay, this one will represent or will give us the form of the function, as I mentioned or introduced a while ago or in the beginning, that for y, for the horizontal and vertical translation, which can be written as y minus k equals f of x minus h. Do not forget about our form, okay? So without it, you cannot really write an equation. Okay. So after that, okay, now you have to obtain the graph of g of x. The graph of f of x equal to x squared has been translated to 4 units to the left. Okay, 5 units down also. Of course, so h is equal to negative 4 and k is equal to negative 5. So now, to write the equation in the form of y minus k is equal to f of x minus h, substitute negative 4. Okay, so, and of course, substitute negative 4 to your h in the equation given in standard form and negative 5 for your k. So you have it. Yeah, substitute it from that equation or function. So now you'll have your final answer as y plus 5 is equal to f of x plus 4 after substituting. So the image point is the point that is the result of a transformation of a point on the original graph. So I hope we are clear about this one. So is the process clear? I hope it's clear. If it's not clear, then we can go to the next example, the letter B. Or in letter B, of course, same instruction. Oh, sorry. Same instruction as we had in letter A, for example, 3. So what will we do first? Again, of course, identify, begin with the key points on the graph of f of x, then locate the corresponding image points. So as you can see in here, this is our base function. It's very obvious. Okay, our base function for year A, you have it -5. Okay, it's here, -5, -2, then -4, 4, as you can see, so on and so forth until 3, 3, 3, 3, it's here. Okay, 3, 3, it's here. So now your g of x, to identify the image points. Again, the image points. These are the transformed coordinates from the base function, or from the points of the base function. Okay, from the key points of the base function transformed to an image point. So that's what we call the image point. So we name it g of x. So as you can see here, your a prime. Okay, from -5 to it gives you -1, -7. So from -1, you have it -7. You can locate it there. So we'll just follow it, of course. Yeah. So after that, as you can observe, what have you observed? What have you observed? We can say that we just, okay, try to observe from, let's borrow the negative, the a and a prime. Your a is -5 and 2. So it is transformed into a prime, which is -1, -7. So as you can notice, for your x, the pattern here, from -5 to -1. So what happened? We just add 4, correct? To have or to get -1. That's why we have x plus 4 in here. What happened to your y? From 2, it gives you -7. So it's just like you are subtracting -9. So that's why we have y minus 9 here. Okay, so I hope it's very clear. Yeah, it's very clear. Perhaps just don't miss the discussion so that you'll not miss the pattern. Okay, now. So now, I'm always saying okay. So let's see now. Now we have, it is common. It is a common convention to use the a prime if you want, so that you will not be confused about it in naming the points or the image points. So to obtain the graph of g of x, the graph of f of x has been translated, of course, 4 units to the right and 9 units down. So substitute h is equal to 4 and k is equal to 9 to the, of course, to the function, to the form of y minus k is equal to f of x minus h. Now your function will give you y, or the equation of this function will give you now, the transformed function rather, will give you an equation. Y plus 9 is equal to f of x minus 4. So I hope you're clear about this one. So you'll do the task number 2, then do the, yeah, still plenty. Then do the homework, then do the exit card rather. And of course, you can submit it online. Then we call it a day. Okay, so that's it. That's the end of our discussion. It's very short, but it's very comprehensive. I hope every one of you will be able to grasp the concept about it. Do not forget that the essence of mathematics will not make simple things complicated, but to make complicated things simple. Okay, have a great day.